Hello students, Stride here again. Today we are looking at section 1.4, presenting scientific data. Order for news to be useful must be reported in a clear, organized manner. Just like the news, scientific data becomes meaningful only when they're organized and communicated. Communications will include visual presentations, such as graphs, like this one. So, how do scientists organize data? One of our key questions. You can organize data by using data tables and graphs. Data tables, we showed here, is the simplest way to organize data. Put them in a table. Table typically will have two variables, a manipulated variable and a responding variable, in this case location and average annual precipitation. Line graphs, another very useful tool. Very useful for showing changes that occur in related variables. In a line graph, manipulated variable going to be plotted on the x-axis. The responding variable will be plotted on the y-axis. Frequently when we're looking with line graphs, it might yield a straight line, and the steepness or slope of this line is the ratio of the vertical change to the corresponding horizontal change. From algebra, you might remember the symbol for slope is m, and we use the little simple phrase rise over run. Delta y or over delta x, another way to think about it. Plotting the mass of water against the volume of water yields a straight line. That straight line, we see the slope here is 5. That slope corresponds to the density. And slope will always typically yield some type of thing. The slope of a distance time graph would yield our speed, which we'll work in the beginning of second semester. A direct proportion ratio of two variables is always going to be a constant. Relationship between the mass and the volume of water is a direct proportion. 3 cubic centimeter, mass of 3 grams, 6 cubic centimeter, mass of 6 grams, 9 cubic centimeters, and mass of 9 grams. The ratio is always 1. Now this graph shows how the flow rate of a water faucet affects the time required to fill a 1 gallon pot. And it makes sense, the faster it is, the less time it takes. The slower the water flows out, the more time it takes. And we gets a nice little curve here. This is an example of an inverse proportion, which the product of two variables is a constant. 0.5 gallons per minute will fill the pot in 2 minutes. We multiply those and we get 1. Flow rate of 1 gallon per minute, 1 minute. Multiply them and you get 1. 2 gallons per minute, 0.5 minutes, multiply them and you get 1. The product's always the same. Modem, device used to send and receive data. If you upload an image to the website, the modem converter converts the data into a different format. Converted data is sent through a telephone line or a cable TV line. Smallest unit of data that can be read by a computer. It's a binary digit or bit. Bit is either a 0 or 1. Computers process bits in larger units called byte. A byte is a group of 8 bits. Table here shows data transfer rates for modems used in home computers. So, got different transfer rates, time to upload 1 megabyte. Notice that as the transfer rate gets higher, this gets higher, this one is getting lower. So this is going up, while this one's going down. That's one way we might recognize what would be an inverse relationship. So if we plotted this data on a graph, see all the different kinds plotted here, and we get that nice little curve that indicates the inverse relationship. If we would double the transfer rate, how's it going to affect the upload time? So doubling the transfer rate halves the upload time. As one goes up, the other one goes down, and at the same rate. Bar graphs. Used to compare a set of measurements, amounts, or changes. The bar graphs are used to compare different items, like here, different cities. Circle graphs work very nicely for percentages. And it says here, if you think cutting the pie into several pieces, you have a mental model of a circle graph. A circle graph, often called a pie chart. Circle graph shows how part or share of something relates to the whole. It percents, you see percents work very well with circle graph. Notice all these percents here. Another key question, how can scientists communicate experimental data? Communicate results by writing in scientific journals, speaking at conferences, a couple of the big ways. Some of the other ways, and just through talking with various scientists, doing emails, making websites, and young scientists, maybe a science fair. Peer review, key process in science work. Peer review, scientists examine other scientists' work. Encourage comments, suggestions, questions, criticisms. And based on the peers' responses, scientists can reevaluate their data. And as we finish up most of the notes, a few quick review questions. Many times again, these review questions will appear on quizzes, or at least something very similar to them will. Type of graph most useful for showing how part of something relates to the whole. Just had that a minute ago. That's our circle graph. How does a line graph generally show the relationship between the manipulated and the responding variable? Manipulated variable plotted on the x-axis, responding variable on the y-axis. How do scientists communicate the results of scientific questions or investigations? One of the last things we had in their notes: journals, conferences. Why is peer review an important part of the scientific process? It can help identify errors or bias. And that's our 1.4 notes. Again, always take good notes. And you're going to use your notes on your quizzes. And that's all for now. Until next time, this is Strike.